This is the fourth problem on the MinMax worksheet, and it is also the problem that we did in class with actual paper and scissors. Now on this one, it's sheet metal and the shape is different. It's 12 by 12 instead of 8.5 by 11, but the idea remains the same. Hopefully, by doing the process with scissors and paper, you realized what exactly was happening with this box. That's a square, 12 by 12. And then you cut little squares out of the corners and fold it up the box. So the key is realizing that your variable should be the width of these little squares. Then it brings to mind that what's going to happen is that your area, your piece of sheet metal is 12 inches square. So the width will be 12 minus 2 x's. And your height will also be 12 minus 2 x's. And those are your constraints. The problem says you want to find the largest volume of the box. So your target, largest volume, you're going to maximize the volume. And your volume is going to be your width times your length times your height. Now your height is going to be x because that flap will fold up to form the side. Using substitution, you get the equation 12 minus 2x times 12 minus 2x, or squared, times x. You can imagine that your x is going to have to be somewhere less than 12. So when we create that graph, it's just going to be 12 minus 2 x's squared times x. And the window, the most it could be is if you went all the way to the middle. And since it's 12 inches by 12 inches, that would be 6. That would be the biggest your x could be. Now, it's not going to be 6. It'll be smaller than that. So your y stands for volume. I would think that your maximum volume would be somewhere around 3 by 6 by 6. That's probably a good guess. I just picked the number 3. 2 times 3 is 6. 12 minus 6 is 6. So my max is going to be 3 times 6 times 6. It's kind of rough. I'm going to double it because all I need is a picture. And there's my shape, which you can interpret. You notice it's a third degree polynomial. This number is squared, and then this one is multiplied. So third degree, and you can see that that value, that curve is going to continue up. That's a strange thing about having negative length sides that cancel out. It's going to be